today is the third and final day of solving trig equations notes. This is going to follow the same layout of the previous notes, where I start with an easy algebra problem to show you what we're doing, and then 2 trig problems. First problem, problem A. This is the easy one. X squared minus 2x minus 8 is equal to 0. More factoring. What do we call these types of problems? We will do slide and divide, but more general, like that setup. I think I heard someone say it. Starts with a T. Trinomial, exactly. Trinomial. Ax squared plus bx plus c, that form. So you need to factor that. This one won't require slide and divide, as the first number is 1, the a is 1, but we will do one later that requires it. So we just need a simple ACB chart to get us through this problem. If you learned guess and check last year, you're more than welcome to do that instead. So I'll set up my factors. We got x's in the front. And AC, that's a times c. That would be 1 times negative 8, that's negative 8, and b is negative 2. Since the AC term is negative, we're subtracting on the right side to get that negative 2. 8 only has 2 pairs of factors, 1 in itself and 2 and 4. If I subtract 4 and 2, I can get 2. To end up with negative 2, the 4 must have the negative on it. So these are my factors: x plus 2, x minus 4. From here, I have my factors equal to 0. I can split them up into their own separate equations, equal them both to 0, and solve them separately. We have x plus 2 equal to 0, and x minus 4 equals to 0. Solving, I get x equals negative 2, and x equals positive 4. Questions on that first problem? Okay. Next problem, we're going to put trig into that. This one will be more painful on the algebra, but less painful on the trig part. We have 2 sine squared x minus sine of x minus 1 is equal to 0. Reminder, if you struggle to see, bless you, the algebra that needs to be done, bless you, we can rewrite this with just x's so you can see what you need to do from there. So that would look like this: 2x squared minus x minus 1. If you need to see just the algebra, you're always welcome to do that. But I wouldn't recommend solving that fully. I recommend still solving with the signs so you don't forget about them later. So as you can see, this is a trinomial. This time we do have a number in front for the a that is not 1. So this is where we will have to do the formal slide and divide along with the ACB chart. So instead of x's, we're going to have signs in the front of both of these. And if you remember slide and divide, you'll know that after you get these two numbers here, whatever they turn out to be, you then come through and divide both of those by that 2, and then you perform slide and divide with that. if you're new here, one thing I like to do is go ahead and put that step in there. Go ahead and write it down. That way when I get to it, my 2 is already there and I don't forget about it later. So I'm going to go ahead and put that divide by 2 in both places. That way I've already thought about it, put it there, I won't forget it later. Now I will do the ACB chart. A times C, 2 times -1, that's -2. B is -1. 2 only has one pair of factors, 1 in itself. And I forgot to point out, since this is negative, we're subtracting on this problem. When we subtract these, you can clearly see we'll end up with 1. To get -1, the 2 has to carry the negative to make that work. These are my 2 factors. So we have sine of x plus 1 over 2 and minus 2 over 2. And now we can move directly into the slide and divide portion. Slide and divide are options. If we can't divide and get a nice number, we will slide. 1 over 2, 1/2, that's a decimal. We can't reduce it, so we'll just move the 2 in front of the sign. 2 sine of x plus 1 times, these 2's give us just a 1, so we can just divide. Sine of x minus 1, all of that is equal to 0. Yes?
I thought when you circled the 2, you had to multiply it by the c value on the product side.
Yep, that's how I got the -2 here.
Oh.
And then you also come through and divide it later.
Okay.
Yeah. All right, this is how it looks when it's factored. Now we can split them up and solve them separately. And I'm going to give myself plenty of space here. We have 2 sine of x plus 1 is equal to 0. And sine of x minus 1 is equal to 0. Solving the left side, the left equation, first we'll subtract 1 on both sides. 2 sine of x is equal to -1. Divide both sides by 2. Sine of x is equal to -1/2. I'll stop there for now. I'll come back in a moment to find those actual x values. I'm going to come over here and solve this equation as well. Sine of x minus 1, that one's easy. We're just going to add 1 to both sides. Sine of x is equal to +1, and I'll stop there. Now we need to find this information. You're welcome to use your graphing calculator and then make the graphs, but it's even easier if you recognize that these are on the unit circle. So just grab the unit circle and identify where this is true. So sine of x equals -1/2. Reminder, this is where y equals -1/2 on the unit circle. That's what that means. So we're looking for 2 x values, and there are going to not be any rounding, so they're going to be equal. -1/2 on the unit circle, we're looking at the y values. It's going to be quadrants 3 and 4. That's at 210 and 330. Those angles give us -1/2 for the y value. So 210 and 330. That's 2 of my answers. And we'll do the same thing on the right side. Sine of x equals 1. That's where y equals 1 on the unit circle. And this one you'll definitely want to use the unit circle because it only actually has one angle, not 2. And that's because it occurs on one of the axes. Y is 1 at 90 degrees and only at 90 degrees. If you go to its opposite, that's -1, so that's not going to be the same. 90 degrees for when sine is 1. Only 3 answers this time instead of 4. Questions on this problem? Okay. This next one, the algebra, will be a tad easier, but the angle part will be a little bit more painful. However, you guys did really well on this part of the quiz, so honestly, you probably won't find this as hard. Last problem, problem C. Tangent squared x minus 5 tangent x plus 6 is equal to 0. Reminder, if you need to see this as just a plain algebra problem, you're welcome to write it with just x's. That would be x squared minus 5x plus 6 for comparison. No number in front besides 1, so this is just a very straightforward ACB chart to solve. AC, that's 1 times 6, that's 6. B is negative 5. And since AC is positive, we're adding to get that negative 5. 6 has 2 pairs of factors, 1 in itself and 2 and 3. As you can see, we can add 2 and 3 to get 5. To make it a negative 5, they both must be negative. So these are my factors. So we have tangent x's in the front. And then my factors are tangent x minus 2 and tangent x minus 3. As you can see, these are not going to be nice. They will not be on the unit circle. From here, we can split these up and solve them separately. We have tangent of x minus 2 is equal to 0. And tangent of x minus 3 is equal to 0. Quick to solve. Tangent of x minus 2 equals 0. I'll just add 2 to both sides. Tangent of x is equal to 2. And I will pause there for now. I'll return in just a moment. Tangent of x minus 3 equals 0. Just add 3 to both sides. Tangent of x is equal to positive 3. This is where you'll need your calculator. We need to algebraically solve for x. We can't just look at the unit circle. So the left equation first, we have x equals inverse tangent of 2. And then we'll use our calculator to get that first answer. Inverse tangent of 2. Make sure your calculator is in degrees when you do this. And then don't forget to convert to DMS as well. Second apps to do that. We end up with 63 degrees, 26 minutes, 5 seconds, so we will not be rounding this up to 27. We'll just have 63 degrees, 26 minutes. That's our first answer. And reminder, you always look for 2 answers. This first answer was in quadrant 1. Let's figure out what the second answer should be. We remember our acronym, all students take calculus, or all students think college, whichever one you learned. So our first answer was in quadrant 1, and we're working with where tangent is positive. Tangent is positive 2. So the other positive quadrant for tangent is the T quadrant, quadrant 3. So Q3 is where my other answer will be found. From here, I will graph to identify that exact value. First, let's graph the quadrant 1 answer. First angle in quadrant 1, angle of rotation. We know this is 63 degrees, 26 minutes. And quadrant 1 is nice because alpha will always be equal there to the angle. So our alpha is also 63 degrees, 26 minutes. Now we will draw the other graph in quadrant 3 to identify what that angle is. The unknown angle is in quadrant 3. Angle of rotation from the start all the way up to where that angle ends. Alpha is always drawn from the x-axis to where the angle is located. And we already know this number. It's 63 degrees, 26 minutes. And reminder, this is 180, just above it. So if I put the two angles together, the 180 and the alpha, that will give me my missing angle. So our calculation is 180 plus alpha, which is 63 degrees, 26 minutes. Adding that together, I won't show it on the calculator. You'll get 243 degrees, 26 minutes. If you type it in correctly, don't forget to convert to DMS. So that's our other value. 243 degrees, 26 minutes. There's the first two answers to this problem. We'll have to repeat all that again with tangent equals 3. Questions before I do that? Okay. Now, a lot of the work is going to repeat itself, so that's convenient. X equals, we'll do the inverse tangent of 3. Again, we're going to get two answers. Inverse tangent of 3, again, I won't show it in my calculator just for time, but type it in correctly, you will get 71 degrees, 34 minutes. That is also in quadrant 1. So we're going to have just a repeat of the previous problem. The other angle will also be in quadrant 3. And that's because we have both positive tangent values, and they'll share the same quadrant. So they're going to be both positive or both negative. Wouldn't work any other way. So we're going to do the exact same calculations. I'm going to draw the graphs, but really you could skip that. I'm going to be honest, since the work works out the same. Quadrant 1, we have 71 degrees, 34 minutes. And again, in quadrant 1, alpha is going to be the same measure. So alpha is also 71 degrees, 34 minutes. And then we graph the quadrant 3 angle to figure out what it is. Missing angle in quadrant 3. Angle of rotation up to where the angle ends. Alpha drawn from the x-axis to the angle. And we now know that value is 71 degrees, 34 minutes. And because we're in the same quadrant as before, the calculation will be the same, just with the new value of alpha. 180 plus, this time alpha is 71 degrees, 34 minutes. Using the calculator, you'll get 251 degrees, 34 minutes. That is the other value of x that we're looking for. There you have all 4 answers to this problem. Reminder, always look for 4 answers, 2 per x value. But sometimes you'll only end up with 3. Very rarely will you end up with 3 or 2. Questions on that?